Hi, I'm Nick Raboy from MongoDB, and in this video, we're going to see how to leverage AI to help us when it comes to our database migrations. So when it comes to MongoDB, there's a tool called Relational Migrator. It's very useful when it comes to migrating your data and schemas out of a relational database into MongoDB. But today, we're going to be focusing on the query aspect of things. So we're going to see how to take our SQL queries from our production applications, use AI, and generate MongoDB compatible queries and aggregation pipelines that we can then go ahead and drop directly into our projects. So not only will it convert to a MongoDB query or aggregation pipeline, but we can also have it spit out the actual code to make it possible. So up on my screen, you'll notice that I am using Relational Migrator 1.6.0. This is a tool that you can download from the MongoDB website and install locally on your computer. Now what you can do is you can go ahead and select a project that you're already using if you're already familiar with Relational Migrator, or we can say create a new project. And within this screen, you'll have the option to either connect your live database, load from a schema, or use a sample schema. Now for the purpose of this demo, we're just going to be using a sample schema. So in other words, there's not going to be any data associated with this example, but we will have a schema for a relational database to use and make queries based on it. But it's totally up to you which option you want to choose. So we're going to say create sample schema. Now for this particular sample schema, we will be using this sample Northwind database, which is a customer and order database. Some of the tables that it contains include customers, employees, order details, orders, things like that. And each of these tables will have X number of columns, and these tables will be related in some sense or another. So let's go ahead and select that Northwind database and click Next. For the purpose of this example, we're going to choose to use a MongoDB schema that matches the relational database schema, because the point of this example is not to show you how to properly model your data, where our purpose is just to show you how to query it. So let's go ahead and click Next. We're going to give it a name. I'm going to say Demo, and I'm going to say Done. Now, after the project is created, you'll see that we do have our relational database sample, which is Northwind. We have these fancy ERD diagrams. If we switch over to just relational mode, we can zoom in and we can see what each of these tables have schema-wise. So we can see that they have primary keys. They have some kind of linking involved to other tables in this data set. But with this information, we can construct a few queries. So for the purpose of this example, let's just focus on the orders, order details, customer information. We won't focus on any of the employee data or territories, things like that. Although you could very easily do that if you wanted to. And like I said, you could use your own data as well. It's totally up to you. So what we want to do is we want to click on the code generation tab of Relational Migrator, and we want to navigate to the query converter area. Let's go ahead and start using the query converter, at which point we can either import from a database or we can paste a SQL query. Importing from a database will allow you to use stored procedures or views, but for the sake of this example, because we are using a sample schema that contains no data, we're just going to paste our SQL queries directly. And these are fictional SQL queries. They are real. If you were to load this data into, say, Postgres, MySQL, something else, and run them, they would work. But let's just go ahead and see what they would look like in MongoDB terms. So this is what you would get. You would have this window that will allow you to enter SQL queries. Let's go ahead and start with a very simple query to see where we're going to start with. What I'm going to say is I'm going to for now select asterisk, and I'm going to say from. I'm going to say customers, and I'm going to say where country equals USA. So customers being our customers table. We do have a field in that customers table called country, and we're going to narrow it down to, say, for example, USA, even though there's technically no data in this example. I'm going to use fictional ideas here, and we are not projecting any particular set of fields. We're just going to get all of them with this wildcard. As far as the target languages go, we can choose JavaScript, we can choose Java or C#. More will come in the future, but for the sake of this example, let's go ahead and use JavaScript. And I'm going to click Convert. Now, it might take a few seconds to a few minutes to complete. Remember, we are using AI to generate this. There is a process involved behind it. But by the end of it, we should end up with something like this. So in this case, once again, we are selecting all fields from this particular table. Customers, where country equals USA, so country being our filter criteria. So in the sense of MongoDB, let's say that our customers table is also our customers collection. We're doing a find operation, and the filter criteria is where country matches USA. Now, if you run this query multiple times, you may get multiple answers. That's just the nature of generative AI. This is a fairly simple query, so your answers probably won't differ too much, if at all. And in this example, the query does look to be perfect. When it comes to more complicated queries, expect that your queries may not work 100% out of the box. So you will need to test and verify, like this little notification says, before you start deploying in a production environment. So let's go ahead and take it a step further. We're going to do another query. We're going to make it a little more complicated as we go down the line. This time around, let's go ahead and specify what we want. Let's go ahead and say that we want the country, but let's go ahead and say that we want to know all of the customer counts per country. So how many customers there are in any given country. So we're going to remove this where condition, so this filter criteria, and we're going to change it to a group by. So we're going to group by country. And we're going to do some kind of aggregation here. So we're going to say count. We're going to count all of the results for the grouping. And we're going to alias this as total. And we're going to see what we get when it comes to MongoDB when we say convert. So we got some results back. It does look a little different this time. So instead of the find operation, we're now doing an aggregate. So it was smart enough to determine that we need to do something a little more complex than just a find. In this case, we're using the customers collection. We're doing an aggregation pipeline. This particular aggregation pipeline only has one stage in it because we don't have more complexity, but we will soon. This one stage contains a group. We're grouping by the country. We're totaling, so we have this field called total, and we're summarizing each of the results, which basically gives us the same answer that we would when it comes to the SQL query. So everything looks good so far. Let's go ahead and continue to complicate things. So as you saw, based on this particular schema, we do have quite a few tables and we have quite a few relationships. Now, when it comes to a relational database, we know that the join operation is pretty common. So we're going to be joining data from different tables. So let's go ahead and see what that looks like in MongoDB when we convert a more realistic query. So for this particular query, I've gone ahead and pasted it in, but we'll go ahead and explain what's happening here. So we're selecting from the orders table. We're joining customers. So customers has a customer ID that relates to the orders customer ID. We're joining a second table here, or in theory a third, and we are joining the order details because orders doesn't have information like the price paid and whatnot. So we're joining based on the order ID that's found in the particular order and the details of that order. Finally, we want to know which products were ordered for this particular, you can say receipt or transaction. So we are joining the products table. The products table is joining on the order details because the order details does have a product ID in it. Finally, what we're doing is we are grouping by customer name. So we're grouping by what orders did any particular customer make. So we have a customer name, and we're also creating a sum of the price. So we're getting the grand total of that particular unit price for the orders. Now, this may not be a realistic query in your data set, but it could look similar in the end. And we'll reevaluate what the actual diagram looks like. But let's go ahead and say run. All right, so finished. So let's take a look at the result. So once again, we're doing 3 different joins, and we are doing a group by. So in this particular aggregation pipeline for MongoDB that it generated, once again, we're querying on the orders collection. We're doing a lookup, which is how you do joins in MongoDB, and we're doing a lookup based on the fields. We are unwinding that information because the lookup returns an array. We're doing a second lookup, so a second join based on the new data here. Same unwind. Once again, a third lookup, just like what we're doing when it comes to the join operations. Finally, what's happening is we're doing a group. So once again, we're doing a sum. We're calling it spent like we aliased it in our SQL query. And we are projecting only the fields that we want. Because at the end of the day, we are database developers, and we know that we probably shouldn't be using the asterisk character to return all fields, especially when we're doing 3 joins. Instead, we should return only the fields that we want so that way we can maximize our latency between our application and our database. Now, you can get pretty complex when it comes to these converted queries. So if you do have a production application and you have a diverse set of queries, some complicated, some not complicated, the query converter functionality of the Relational Migrator tool can help you significantly. Now, I do want to reiterate a few things. One, it can take a few seconds to a few minutes to calculate a AI generated query for MongoDB. So give it some time to run, and you should be pleasantly surprised by the results. Now, the results may or may not be 100% accurate to what you're expecting when it comes to a conversion. This is AI, it's going to do its best, but like this note says at the top, always check and verify that the query gives you the results that you're looking for. And finally, the third thing that you should note is that you can run it 3 different times and you could get 3 different results because that is the nature of AI. So you may get a different result each time. All 3 may work, but once again, you are testing to make sure that they work to your liking. If you want to learn more about how to migrate your relational database efforts to MongoDB, that includes the data, the schemas, or the queries, go ahead and head over to the MongoDB Developer Center, so developer.mongodb.com. You can learn from a variety of tutorials. You can also ask your questions in the MongoDB community forums, which can be accessed from mongodb.com/community. If you like this video, please go ahead and give it a thumbs up and then like and subscribe to this particular YouTube channel, and I'll catch you on the next video.